expectations and variances, variances of continuous random variables. So we start with number one, expectations. So how do we define an expectation? So let the random variable be x. Let the random variable be x. Then expectation of x is given by the sum, because it's a continuous random variable, from a up to b, where a and b are limits of integration, x fx dx. Fx is the probability density function because it is a continuous random variable. So for example, e.g., if you have a random variable x, for a random variable x, with a range 0 2, this is a closed range 0 2, and the PDF of f of x is equal to 3 over 8 x squared. So we want to get the expectation. We apply formula. Let's call this one formula 1. Let's apply formula 1. We say expectation of x will now be the integral from lower limit 0 up to 2 x fx dx is 3 over 8 x squared dx. So this is the same as 3 over 8, the integral 0 up to 2 x raised to power 3 dx. So we integrate this. This one becomes 3 over 8 x raised to power 4 divided by 4 from 0 up to 4. How do we get this? This is the same as 3 over 32 x raised to power 4 from 0 up to 4. 0 up to 2. The highest limit is 2. How do we get this? This is 3 over 8, 3 over 32 into 2 raised to power 4 minus 0 raised to power 4. So this is the same as 3 over 8, 3 over 32 times 2 raised to power 4 is 16 times 16. This is 1, this is 2, this is 1.5. So that is the expectation of that random variable. Then we have the variance. The variance of the same random variable. We know the formula for the variance. Variance of x is equal to expectation of x squared minus expectation of x, but this one now squared. We know the expectation of x. We have calculated it. So it means we have expectation of x squared minus, this is 1.5 squared. 1.5 is what we have obtained from the expectation of this random variable in the first question. So it means we have to find the expectation of x squared. Expectation of x squared is the same as the integral from 0 up to 2 x squared fx dx. We differentiate with the rest, we integrate with respect to x. How do we now? From here we say this is now the PDF is 3 over 8. The PDF is here, 3 over 8 x squared. So we have the integral from 0 up to 2, 3 over 8 x squared. That is the PDF, that's fx but we also have x squared with respect to x. We can factor out the constant, that is 3 over 8 into the integral from 0 up to 2 x raised to power 4 dx. Now integrating, we get 3 over 8 x raised to power 5 over 5 from 0 up to 2. This is the same as 3 over 40 x raised to power 5 from 0 up to 2. This one is the same as 3 over 40 into bracket 2 raised to power 5 minus 0 raised to power 5. This 3 over 40 you multiply by 2 raised to power 5 is 32. So 8 goes there 4, 8 goes here 5. So we have 12 over 5 as the variance, as the expectation of x squared, not as the variance, as the expectation of x squared. But now we go back to the formula for getting the variance. We said variance of x is equal to expectation of x squared minus expectation of x, this one squared. We have got the expectation of x squared, which is here 12 over 5 minus the expectation of x squared is 3. The expectation of x squared is 1.5 squared. This is the same as 12 over 15 over 5 minus 3 over 2 squared, which is the same as 12 over 5 minus 9 over 4. The LCM is 20. So 5 goes in 24 times. 5 goes into 24 times, that is 4 into 12, minus 4 goes into 25 times, that's 5 into 9. So we get, this is 48 minus 45. This is 3. You have 3 over 20 as the variance of that random variable.